It's exciting to be back here and to see way more people than last time. So round of applause to all of you for showing up. Can't wait for next year already. Okay, so this is teaching Elm to beginners. But first, I want to ask a question. Quick show of hands. Anyone here using Elm at work? Whoa! I was not expecting most of you. Wow, that's incredible. Okay, those of you who didn't raise your hand, anyone here want to use Elm at work? Yeah, all right. I think unioning those two sets, that's like everybody. So something that I've learned about using Elm at work is that actually using Elm at work involves teaching Elm to beginners. This is kind of the story we hear over and over, is that you have somebody who's sort of the champion, is like, hey, I think we should use Elm, and then they end up inevitably teaching Elm to coworkers who don't know it yet. So whether you're using Elm at work or not, this is something that's going to be valuable to you. Okay, so teaching Elm to beginners is something that I've actually ended up spending a lot of my last couple of years doing. So for the front-end master's course that Brian mentioned earlier, I actually spent over 100 hours in classroom settings teaching Elm to beginners, and even more hours, more than I really want to think about, writing and revising Elm in action. So with all of these hours, one of the things that I learned that kind of surprised me starting out is that teaching is a totally different skill set from programming. I've spent so much of my life programming and honing my craft and getting better at it, and then kind of getting into teaching, I was like, oh, this is actually completely different. I don't know anything anymore. But one of the other things that I realized is kind of it's okay. It's normal not to be an expert at teaching just because we've spent all this time learning programming. But since, as previously noticed, teaching Elm to beginners turns out to be an important part of using Elm at work, this talk aims to help you with that. So in 3 specific ways. So first, we want to talk about distinguishing between facts and understanding. This turns out to be a really important distinction. Second, by making a plan for figuring out how to reach your learning goals, like a concrete plan. And finally, Elm-specific, we're going to talk about how to introduce Elm types at a good pace. And this is really one of the most important parts, I think, about teaching Elm to beginners. Okay, so let's take a scenario. We've got a question from a coworker. We just started using Elm at work. They kind of got the basics down a little bit, but they have this question. They're like, hey, why can't I just write HTML instead of HTML message? And this is actually a question I've gotten from a coworker at some point. This is maybe something that you've gotten from coworkers. Why not? Okay, so I'm going to take a stab at answering this. Okay, here we go. Differences between HTML and HTML message. All right, so first of all, HTML message has a different kind than HTML. So the kind of a type is basically the types type. And so HTML has the kind star to star, and string has the kind star, with me, and HTML string must therefore also have the kind star, yeah. So based on that, by the way, you can actually take that a step further and realize that function application has the type star to star to star. Anyway, getting back to the point, so Elm views must return types of kind star, so views returning HTML would be a kind mismatch. Okay, cool. If you're like me, you've probably heard some variation of an explanation like that before. Maybe not in Elm, maybe in other communities, but whenever I've heard something like this, my reaction has been kind of like, what? Am I dumb because I didn't understand that? I didn't get there. If you think about it, this shouldn't be super surprising that that's a common reaction to things like this, because it's like we started off, we had this one new concept to understand, right? The question the coworker asked was, hey, why is it HTML message instead of HTML? And then the explanation was this, which basically was like, okay, cool. Let's start by talking about kinds. Now we have a second concept to understand. The kind of a type is the types type. What is a types type? Now we have another concept to understand. And then HTML is, what are these stars are happening? And then HTML string has a kind star, which must follow from the others. Why did it follow from that? So we just keep adding more and more concepts that need to be understood, and none of these end up ultimately, in a particularly direct way, answering that original question. So if we teach this way and students end up being confused, we shouldn't be terribly surprised. So let's not do that. Forget all that. Let's kind of reboot, take a step back, and just start by saying, okay, wait a minute. What does success look like? That was not what it looks like, but what does actual success look like? And so I like to go to this quote. This is, the success of any teaching activity is defined by what students actually understood. That's the goal. That's what we're aiming for. This is a quote from Jeff Scheuer, who's the founder of NoWrite Inc., where I work. He was an English teacher for many years, a successful one, and then he ended up founding an education company, and now we all write Elm there. By the way, we're hiring. And I really like this as a metric for success, like actual understanding. Not just knowledge, but understanding. So we're going to come back to this idea. Okay, so with that in mind, we got, okay, here's where we are now. This is where the student is. And where we want to get them is actual understanding. And hopefully our teaching is going to be a direct path from the one to the other. Okay. So in this particular case, the understanding that we're going for is they want to understand, like, hey, why can't I just write HTML instead of HTML message? Now, what I started out with in my earlier explanation was I said HTML message has a different kind than HTML. Now, getting from where they started out to understanding the answer to this question by way of kinds is a very convoluted route. I mean, it's not direct at all. Like, there's a lot of twists, a lot of turns. We're going to go on tangents, and then we're going to hopefully come back. And students aren't necessarily going to come with us on this journey that we want to take them on. Like, this coworker of mine just asked a question. They said, why can't I write HTML instead of HTML message? I'm like, let me tell you about kinds. It's really important that we don't lose people on the way to trying to get them understanding. We can't take for granted that just because we want them to end up in understanding and just because they want to end up in understanding that they're necessarily going to follow us on any path we choose to take them there. So find a direct path. That's what we want to do. Find the most direct path to getting them the understanding that they want. So a useful technique towards doing this is framing the goal itself. And there's a really nice acronym that teachers use for this called SWAT. And SWAT stands for students will be able to. I heard somebody say in the audience, yeah, probably some teachers here. So the idea behind this acronym is to sort of start off a sentence with students will be able to, and then fill in the rest of the sentence. And that's the goal. That's our concrete goal. Once we're done teaching them, we should be able to say that sentence and have it be true. Students will be able to do this thing. So in our case, why can't I just write HTML instead of HTML message? We're going to frame this goal in terms of SWAT and say, by the end of this, students will be able to explain why HTML has a type parameter. Like, explain it to someone else. Because really, I mean, if we think about it, I could explain this to you and say, hey, so did that all make sense? And they'd be like, yes, I don't want to sound dumb. I didn't follow any of what you just said, but yes, because the alternative means I might be dumb. I mean, people have self-consciousness about this, right? So the actual goal is that, hey, I want to say, like, okay, cool. Can you explain that to our other coworker now? Like, can you explain why HTML and HTML message are different? Like, why we have to say HTML message instead of HTML? And that's the goal, like, is that they would actually be able to explain it to someone else. That would demonstrate not just knowledge, but actual understanding. Okay, now to get there, we're going to use this concept of gradual learning, sort of building incrementally on knowledge they already have. And it turns out that this is not just sort of like something that's in the scope of this talk. This is actually built into the fabric of Elm. This is something that Evan thinks about when he designed the language. And he talks about this in this excellent talk, Let's Be Mainstream. He talks about pedagogy and how to go about teaching people these concepts. Like, Elm's design is in large part influenced by Evan's thoughts on, hey, how can we teach these things in a really effective way? And gradual learning is sort of a part of the fabric of Elm. So we're going to build incrementally on students' existing knowledge, and we're going to find motivation. We're going to find out something that resonates with them as to why they should learn the concept that we're about to teach them. Okay, so take two. Why can't I just write HTML instead of HTML message? Hey, that's a great question. Thank you for asking. So let's start by looking at this delete button. So you know how HTML works. We got a button, it's got some text in it that says delete, and let's make it interactive. So we're going to add an on-click handler. I'm just going to say string delete is the message here. Then we'll write an update function that takes message and model, do case message of, and then we'll have some logic here under our what if we get a delete message in there. Okay, cool. So that all works. What's the type of this update function? Well, we can see that we're doing a case expression on message, matching it against a string literal. So message must be a string. And then it's taking a model, and we'll just say it's returning a model. Let's not talk about commands for now. We'll just leave that out of scope. Okay, so we got our delete button. It's making a message that says delete, and then our update function takes a string and a model and returns a model. So now let's say that also we have on the page a hide button, and it's right next to the delete button. Side by side, siblings in the DOM. And we've implemented it like this. Button on click hide, it's got the text hide. But now there's a little bit of a difference here. For this one, rather than a string for hide, we used a custom union type that we made. This is like hide with a capital H, no quotes. So what's going to happen when update runs after the user clicks on the hide button? Well, this hide message, which is not a string, but rather a custom union type that we defined, goes into update. Well, wait, but update takes a string. Does update take a string or this message thing that we defined? Which is it? It kind of like can't be both. And also, what's this case expression going to do? I mean, in some cases it's matching strings, in other cases it's matching union type constructors. What? That's not a thing we can do. So if we were to define both of these at the same time, the Elm runtime would have to decide what to do when it gets a non-string coming into update. I mean, one option, kind of the thing that we've come to expect from JavaScript, is just to throw a runtime type mismatch. We know we don't want that, no crashing. So we're not going to crash. What are we going to do? I mean, probably the runtime's just going to say, I guess I'm going to throw this out the door. I mean, I don't know what to do with this message. I don't know what to tell you. I work on strings. I know about strings. I don't know what this other thing is, so we're just going to ignore it. And we don't want that either, right? So basically, if update and view didn't agree on a message type ahead of time, then messages would just have to get dropped or else crash. So we don't want this. So how can we rule this out at compile time? How can we get Elm to give us an error at compile time if they're not talking the same language? If we've got messages coming in of one type in some case, and then in another type in another case. How can we do this? OK, so we've got update, which takes our string, and a model returns a model. We've got our delete button. So the answer to this question is basically that we encode what type of messages this HTML value produces in the type. So we say delete button is HTML string because it produces string messages. And we can say, oh, at compile time, I know that these have to line up. Whatever value I choose to use for my message, that same type is going to be the first argument to update. And now we've got that encoded in there, so I can get a compile time error if they're out of sync. So again, going back to our hide button example, because that is HTML message, we now see the incompatibility at compile time. The compiler can help us out with this now. And so, in fact, if I tried to put those as siblings in the DOM, we would immediately get a type mismatch because we'd have a list of HTML strings that somehow has an HTML message in it. As we know, Elm lists can only have the same type inside of them. So that wouldn't work. We would get a compile error. Then you say, OK, but I want to put the hide button in there. How do I do that? And now we get into, OK, HTML.map is how we can convert between two different message types. And finally, bringing it all together, this is the actual signature of a program. This is what we're passing to our program. And as you can see, I've highlighted in green, we've got HTML message with a lowercase m, the type variable, and then update, also lowercase m message, so that those type variables have to line up. So if we've got a view function that's returning HTML that produces one type of message, and update's expecting a different type of message, we will get a compile error as far back as the program of our function that kicks everything off. So that ties everything together. OK, so let's recap what we did there the second time. First of all, we started with motivation. We're saying, like, OK, what's the motivation for this? I didn't say, like, oh, here's the answer to exactly the question you asked. The reason it's important to start with motivation is that it greatly impacts the degree to which people take the words that are coming out of your mouth and turning them into understanding. Right? Motivation is all about engagement. It's about people saying, I'm not just taking this in, but I'm actually processing it. I'm not trying to just absorb it and store it away from later, sort of like rote learning. What I'm doing is I'm actually like engaging with it and thinking about it. And motivation teaches people to say, oh, wait, I actually understand how this is going to help me. OK, cool. Now that I understand how it's going to help me, I want to learn it. I'm motivated to learn it by your pointing out to me this problem that it's going to solve for me. OK, so then we gave this example, this concrete example, the on-click with the delete. And then we said, OK, here's one scenario. Introducing the hide button provides that motivation. It says, like, OK, if update and view didn't agree on a message type, messages would either get dropped or things would crash. That is our motivation for why HTML and HTML message are different. Now that we've set up that motivation, then we can explain it. Say, OK, cool. So see how delete button has the type HTML string. That agrees with update. And then we build incrementally from there towards getting to, OK, here's the type of program and how these things interact and how they ultimately make it so that you can get that problem solved at compile time. So coming back to this again, success of any teaching activity is defined by what students actually understood. Now, without kind of surveying the audience, I have no real way to gauge how much people understood from that. But we can sort of see that like this is going to be much more effective than the first approach, where we're just sort of dumping lots of facts on people. Actually, giving lots of facts, even though they may be true, and granted, all the stuff that I said the first time around were true statements, they were valid, our job as teachers is to sort of narrow down this infinite possibility space of facts, all the things in our head, down to just the things that will get students to understanding. So things that are important when doing this, first, figuring out what do my students know. If we're going to build incrementally, we need to know where we're building from. What are the things that are in bounds that I can use as teaching tools that are still things that you understand without my having to explain them separately? I don't want to have to go on a bunch of tangents to get where I'm going. I want to say, OK, you know these things, and I can build incrementally from here. Second thing, again, establish motivation. Right? Figure out what it is that will motivate people to pay attention to what you're saying. And then finally, build incrementally from that knowledge that they already have to get to the next step. Things that are unimportant, but which might seem important. One, being precise, not important. This might be counterintuitive to us, because as programmers, we have learned, we've been trained, we must be very precise when talking to machines. If we're not precise, we get bugged. It's not good. But being precise when teaching can actually work at cross purposes. It can lead you to include lots of things and go on lots of tangents that are not actually important and are potentially quite distracting. This is how you can get a longer, winding road towards trying to get to understanding, and you can lose people along the way. In contrast, precision is, in a lot of cases, something that can be filled in later. Like you can say, hey, remember that thing I told you like 2 days ago? Okay, I kind of lied. It's actually like this. But the important thing is that, hey, they're still with you 2 days later, right? They stuck with it. Second thing that's related to that is details, right? Do not need to be detailed when you're talking about these things. If there's anything that you're doing when you're teaching where you're like, I could mention this and take 30 seconds on it, or you could Google it later in 60 seconds, just leave it out, right? People know how to use Google. If it's something that's that simple, don't worry about it. Trust your students to fill in the gaps later. Focus on the things that are hard to learn, something that they can't Google in 60 seconds. That's the stuff that you really want to focus on when you're teaching, because it's hard enough just to get a new big idea into someone's head where they actually understand it. And finally, it's not important to be entertaining. Like, entertaining can be kind of the icing on the cake, but it can also be pretty distracting. So, like, for example, this is a cat with some lightsabers. That's a pretty good way to get a laugh, right? But the fact is that, like, the words that I'm saying right now, like, most people here are watching the cat with the lightsabers and not listening to what I'm saying. So, as entertaining as this may be, actually the slide was more effective before I added that, because now, at least some of you are paying attention to what I'm saying and not looking at the cat with the lightsabers. Although, let's be real, cats with lightsabers, come on, that's pretty great. Okay, so let's take another scenario. So we talked about what happens when a coworker asks you a question. Now let's say we're teaching a group of brand new beginners at a meetup. We just started the Elm Philadelphia meetup, lots of meetups popping up. Let's say you show up and a group of people comes in and says, hey, I heard about this Elm thing, I think it's cool, but we're all with a JavaScript background, can anyone here teach us Elm? So let's walk through that scenario. So one big difference between this one and the scenario where someone's asking us a question and we're teaching them is now we need to actually design a lesson from scratch. Like, this is a much broader mandate that they're asking us. It's sort of maybe they're asking it in question form, but really we can't just talk about one thing. We need to actually make a plan. Okay, so the first thing to do when designing a lesson is, again, ask the same question. What do my students know? And again, figure out how can I motivate them to learn the next step. And then finally, build incrementally on what they already know. So let's go through this for our JavaScript folks who just arrived at our Elm meetup. What do my students know? Well, they know JavaScript, right? They were very upfront about that. That's where they're coming from. And now their motivation becomes pretty clear. Like, hey, I want to build an app using Elm. That's what I want to do. I want to build a thing and see what it's like. Cool. So let's use Swabot on this. So we're going to set a goal of students will be able to build a working Elm application. That's our goal. This is going to be important because we're going to be tempted to wander off from this goal, but this will keep us focused. The goal is that by the end of our teaching, students will be able to build a working Elm application. Okay, find the direct path to getting them there. Well, first thing we have to do is we have to split up some lessons, because that's too big. We can't just do that all in one lesson. Be like, all right, you don't know Elm? Cool. We're going to sit down and then, all right, now you know Elm, you've built a working Elm application. No, we got to do it a little bit more incrementally than that. So let's split things up a little bit. First, we're going to have to cover some Elm syntax basics. Then we're going to go on to rendering HTML in a basic way. And then finally, go on to the Elm architecture, which is necessary for interaction. So Elm syntax, we're talking stuff like if-then, records, function application. Rendering HTML is like, okay, we're going to have like a button. It's got some text in there, but it doesn't do anything yet. It just says the word delete. And then finally, Elm architecture, actually adding an on-click, adding an update, adding a model, things like that. Okay. So notice, by the way, that each of these builds on the previous one, right? Elm architecture builds on your existing knowledge of how to make a button and how to style HTML and things like that. And rendering HTML, in turn, builds on Elm syntax fundamentals, like using records, using function application. So ideally, you can start from, I want to get students building an interactive Elm application, and then thinking, okay, well, what's required for that? Well, they need to understand the Elm architecture. Okay, but what do they need for that? Well, they need to understand how to render HTML. What do they need for that? They need Elm syntax. And then sort of build a plan in reverse, such that you've now got a nice sequence of steps, each of which builds incrementally on the previous one. This is a gradual learning that Evan was talking about in Let's Be Mainstream. By the way, I have a workshop that I gave for front-end masters, and I open-sourced all of it and made it Creative Commons if you'd like to use it. So take a look, and this is actually directly what I do in that workshop. First teach syntax, then HTML rendering, and then Elm architecture. And we actually do this exact thing right here, where on-click takes a record. So you might be thinking, that's not idiomatic. Why don't we just, like, instead of doing this weird record thing, why don't we just cut to the chase and just show them types? Like, just use a union type like we would normally. And the answer is, remember, students will be able to build a working Elm application. That's our goal. That's where we're headed. We don't want to wander off the path. We want to take the most direct route we can there. And if our goal is to get them to the understanding of how to build an Elm app, we do not need to teach them types to do that. In Elm, you can do all of that, and in fact, that's exactly what I do in Front-End Masters and this workshop. No types at all. No type annotations. I don't even say the word type until they've built an Elm application that works already. Because this is all they need. They need to understand how to do HTML, they need to understand Elm architecture, and they need to understand Elm syntax. They don't need to understand types yet. And going on a detour to teach them types takes them further away from that understanding. It's now a longer, less direct route to where they get to, where they want to get to. All right, so let's say they've now like, hey, we built our first Elm app. Great, I'm happier than a panda eating birthday cake. This is excellent. It works. I click the button, it updates the thing. Sweet. Okay, now what? What's next? Like, our original goal was, hey, students will be able to build a working Elm application, and they did that now. We got them there. Excellent. The next thing is now they want to expand a working Elm application, right? They want to grow it. We're not necessarily into the territory of like scaling per se yet, but they just want to add more stuff, make the application do more. Okay, now they're going to need to understand types. Like as soon as you start expanding stuff, you quickly want to be able to understand types to build on what you've already done. Cool. So now is an appropriate time to introduce them. So now let's do the same exercise. Designing a lesson for teaching them types. What do my students know? Find motivation and build incrementally. Okay, what do my students know? Well, now they know a bunch of JavaScript and a little bit of Elm. They don't know about types yet, but they do know Elm architecture, rendering HTML, and Elm syntax. That's a start. We can build on that. Motivation for learning about types. This is interesting. How do we find something in them that motivates them to learn about types? Because, like, I mean, we made this button, and like, okay, so this already works. Like, why do I care about its type? Like, why bother? Like, we don't need that in JavaScript. We just do this stuff, and then like, why should I care about what you're about to teach me about types? Am I going to fall asleep when you do that? Like, why should I care? What's my motivation? And there's a real temptation here to sort of project our feelings about types onto our students and just like kind of want them to feel the same way that we do. And especially because as we work with Elm more and more, it's pretty common for people to have like, oh, this stuff is like actually really valuable, and you get more and more excited about it, and you get like, yeah, types, oh man, this is so cool, how did I not know about this before? And then you don't realize how you're coming across when you start teaching the students. And and the problem here is that the whole point of motivation is to find something that resonates with students already, right? Something which they feel in their jobs already. They haven't had this months-long epiphany that you've had after building all these things and being immersed in this environment, so we got to figure out something that already resonates with them. That's really important. Okay, so we've narrowed this down. Now we're going to say, okay, how can we find a motivation to learn types that already resonates with our students, who, again, walked up to this meetup only knowing JavaScript? Okay, so here's the example I like to give. Let's say we write a function called double, takes a number, and it doubles it. Returns the number times 2. Great. We had a little comment in there that says, hey, this doubles the number, which is true. Then, much longer in time, the code base grows, and one thing leads to another, and somebody goes and changes this function a little bit. And now this comment is a lie. So something that resonates with, I'm guessing, quite a few of us is having the experience of going through a big code base, and you're like looking for a bug, and you see a function, you're like, that's a complicated function, I don't know what it's doing. Oh, there's a comment that tells me what it does. Oh, okay, that's what it does, got it. Now, the bug must be something else, but it turns out, nope, it was in there. It's just the comment got out of date. Right? This happens with comments. Comments can get stale. Type annotations can't. They are a form of documentation that never gets stale. So this problem that you're familiar with, that you've had in the past, I'm going to show you how Elm gives us a solution to that. And this is going to be important because now we're talking about expanding our application. This is something that's not valuable initially when you're just building the first version of your app, but as we scale, it gets more and more important. Cool. Now you might be thinking, okay, hang on. This is our motivation for learning about types, is like comments can get stale and type annotations can't, but the epiphany, like the types, that's so like, come on, this is all we're doing. It's like, yeah, because we got to find something that resonates. Look, they'll get there. If we can keep them on the road and keep them interested in learning and motivated to keep continuing with this, eventually they'll get there to the epiphany on their own. We don't need to hit them over the head with it. We don't need to present that to them on day one. The key early on is to get them a direct path to understanding the next thing. Okay, so this is a small motivation, but it's a motivation. We've got them through type annotations now. We've taught them that. And now we're like, okay, the next thing to teach them about types is union types. So certainly union types build on type annotations. Once you know float and int and string and things like that, now you can build union types that hold those different values. That's useful. You can do a little exercise where you show how bool is just a union type. That's useful. So we've got sort of the idea of here's how we can teach them union types. So what about motivation for union types? Like, what motivates folks to learn about union types? Or what makes them think this is interesting and worth paying attention to? Okay, here's the example I like to give. We started off with this button, on click delete, and then we changed that, we expanded it and said, okay, now we're gonna have a record. This is probably familiar to people who've used Flux or Redux. This kind of looks like an action in JavaScript. Okay, so we got this record, operations delete, ID is 3, great, that's like a little payload in there. Show them type aliases, say, hey, this is a message, it's got operation string, now we can write nicer type annotations, we don't have to put the whole record thing in our update. Great, okay, cool. And now, let's add a new feature since we're expanding. This is gonna be a new feature that is a little search box. User types in there, and as they type in, we're gonna wanna record the search query in the model, which means it's gonna go through this message, so we'll add search query to our type alias. And now, we have a type mismatch. So this button, our delete button, now returns the wrong kind of record. It's returning a record with 2 fields, but our message type has 3 fields. And as we saw earlier, the message types have to agree. We have to have the same message type coming out of our views as what our update expects. So what we got to do is we got to stick a search query in there. And like, what are we going to put in there? This is a delete button. It doesn't care about search queries. It's like, I guess, empty string. And now you just ask your students, hey, imagine if we added like 20 more things. And like each of those times, we have to go through every single place we instantiate a message in the entire code base and add this new field with some sort of empty value like we did here. And students are saying, yeah, that sounds like it's going to be really awful. I really don't want to do that. And of course, because that would be really awful. What's the solution? Union types. So we highlight this problem. We point it out. Again, this is all information that the students have in their heads already. We're just pointing it out. We're not sort of trying to persuade them to care about it. We're just saying, hey, did you realize that this is going to be a problem? And then pretty soon like, yeah, that is going to be a problem. Do you have a solution to that? You say, yes, I do have a solution about that. Let's learn it. And now they're paying attention to what you're explaining. So we have to find motivation for each individual lesson like this. It's not enough to just say, you're motivated to learn Elm because you came here. Therefore, you will pay attention to everything I say. Each individual lesson needs its own motivation like this. So we've seen 3 examples of this now. So first, we're like, okay, update and view must share a message type. And that's why HTML message works that way. It solves that problem. Then we talked about, hey, comments can get stale. That's a problem that resonates with people. Type annotations solve that problem, or provide documentation that doesn't get stale. And then records for message don't scale, and that leads us to teaching union types. So motivating each of these. This works, by the way, on even bigger curricula than the types of things we're talking about here, with a coworker asking a question or with some beginners at a meetup. So students should be able to, Swobat is a perfectly valid way to design an entire curriculum for teaching people from getting 0 to all the way to building a production Elm application, which gets into things like testing, JavaScript interop, talking to servers. All of these things, it's the same basic concepts. Swobat scales really well. You just have to break things down into smaller and smaller lessons along the way. So building incrementally in this style, start with syntax, move on to rendering HTML, move on from there to Elm architecture, move on from there to types, and then from there, you go on to like JSON decoders, talking to servers. By the way, noticing that talking to servers builds on JSON decoders. Like once you understand JSON decoding, then you can talk to servers, because servers typically want to speak to you in terms of JSON. And then once you understand talking to servers, we can build incrementally on that to talking to JavaScript, since Elm's metaphor for talking to JavaScript is extremely simple to Elm's metaphor for talking to servers. So again, each step builds incrementally on what came before it. And this is exactly what I've done with both front-end masters and Elm in Action. This right here is exactly the order in which I teach things in both of those cases. So some other useful techniques, just sort of general teaching tips. One is scaffolding. So this is basically the idea of explaining, like, here's where we're going. We're going to do these things, and then going through those things in that order. Another is repeating yourself. You might have noticed that I had a couple of slides that repeated themselves. Repetition is useful here. Dry, maybe an idea in programming that does not translate to teaching. We do want to repeat ourselves. Do repeat yourself. Using more than text alone, so not just having bullet points, but actually having maybe photos of dogs with sunglasses, or maybe diagrams, things like arrows, squiggles, right? Ways for people to visualize things other than just reading text. And then, ideally, having your students actually apply these concepts. This is sort of a limitation of this talk format. Like if I really wanted to drive these ideas home, I would say, let's take 10 minutes and use these ideas that we just did. Turn to the person sitting next to you and teach them this thing. That would reinforce it a lot better than my just saying these things and then saying, oh, well, enjoy. Unfortunately, like I said, that's a limitation of the talk format, so here we are. But having said that, this study, this talk actually is a case study in these ideas. So I started off by saying this talk aims to help you distinguish between facts and understanding, make a plan for how to reach your learning goals, introduce types at a good pace. The way that I came up with these is I said, so by the end of this, I hope that students, which is to say the audience of this talk, will be able to do these 3 things. Then I sort of have designed the lessons in this talk. So you may have noticed that I started off by asking, like, what do my students know in a very direct way? I said, like, hey, how many folks want to use Elm at work? And got a show of hands. And this provided the motivation to learn these concepts, right? So I know that my students already know Elm, and the motivation that I'm looking for is, hey, if you want to use Elm at work, you're probably going to have to teach beginners. Now, I'm guessing that quite a few people in here were saying, like, the title of this talk, Teaching Elm to Beginners, that's like kind of interesting, but I'm not really sure how it's going to apply to me, so I don't know, maybe I'll play with my phone. But once you realize that actually there's a very direct connection between doing this and using Elm at work, which is something that we established that a lot of people wanted to do, now you're a lot more interested. There's a lot more reason for you to pay attention. And then finally, of course, build incrementally. You may have also noticed that quite a few things in this talk referenced earlier parts of the talk, because that was part of the strategy, right? Building incrementally. The lesson at the very beginning, the hypothetical question from a coworker about HTML and message, ended up coming up in the other parts of the talk. So just building incrementally on that knowledge. And then finally, finding the direct path, such that, ideally, by the end of this talk, students, which is to say all of you, will be able to teach Elm to beginners. Thanks very much.